Uh, Dinosaur Dig Site.
In its moment of death, the Tyrannosaurus lay on its left side, with its neck stretched back in rigor mortis. The skeleton was found embedded in sandstone, suggesting that it died in a sandy stream bed. The flesh decomposed, and the stream washed some of the bones away. The left arm was carried several feet from the body, where rancher Kathy Wonkel found it 65 million years later. The skull detached from the neck, broke apart, and rolled against the pelvis. The right leg flipped over the body and came apart. The end of the tail and parts of the feet appear to have been washed away altogether.
Uh, 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 Tyrannosaurus discovery. The American rancher Kathy Wankel was walking in the Montana Badlands on Labor Day in 1988 when she noticed some brownish bones sticking out of the ground on a hilltop. She dug down until she could remove the bones, and she took them to the Museum of Rockies in Bozeman, Montana. There, Jack Horner, a paleontologist scientist who studies fossils, identified them as shoulder and arm bones of a Tyrannosaurus. One clue that helped him to identify the bones was the fact that they were discovered in the Hell Creek Formation, rocks dating back to the Cretaceous period, 144 to 65 million years ago. These rocks are the source of most of the world's good Tyrannosaurus skeletons. Uh, the bones were hollow, which indicated a meat eater, and their size, shape, and age of all suggested Tyrannosaurus. Wealth of bones. In May 1989, Pat Leahy, a colleague of Jack Horner at the Museum of Rockies, returned to the hillside of Kathy Wankel's find and uncovered a part of hip bone. 4 months later, he revisited the site and found the skull lying beside it was a right leg. He also found some backbones, a strong indicator that the whole Tyrannosaurus skeleton lay buried in the side of the hill. The following year, in June 1990, major professional excavation was carried out. The almost complete Tyrannosaurus skeleton was unearthed. Dinosaur Dig Site. Shift in the top layer. Here the shift in the top layer, they're using picks and shovels. And sometimes pneumatic drills were drills where the rock is very hard, and excavation team breaks up the overburden, the rocks above, and fossilized dinosaur bones. This may involve shifting tons of rock many meters thick. Once the excavation area has been cleared, the real work of excavating the bones can begin. Breaking up the rock, excavators use sharp picks to split apart the overlying rock so that it can be cleared from excavation area. To mapping out the site. The area to be excavated is mapped with a grid. If the excavation area is large, the grid will be assembled on site with the length of string, scratch, and pegged into the ground. A pre-made grid is with the grid frame may be used on a smaller site. The grid marks out the excavation area and enables the paleontologist to measure out the rough position of bones lying in the ground. Here, the paleontologist, scientist who studies fossils. Paleontology is a science dealing with the life of the past geological periods as known from fossil remains. Portable grid, a pre-made grid is used to map out a small excavation site. Scraping, scraping and chiseling. The once the excavators reach the matrix, materials around fossil uh, work becomes more delicate. The rock or other materials in which the dinosaurs' bones are encased is scraped away from the individual bones. This requires a great care as fossilized bones may be very fragile. Here, the careful work, the excavators use knives and chisels to scrape away the rock, uh, taking care taking care not to touch the bones.
After the bulk of overlying rock has been removed, the delicate work of scraping sandstone away from the dinosaur's bones begins.
Toughening of the bones. As the dinosaur fossils bones are exposed at the rock surface, a clear hardening liquid is poured over them. This liquid seeps into the bones, making them harder, dark, and shiner. It helps to protect the bones, preventing them from crumbling or breaking during the rest of the excavation. Here, the liquid protection hardening liquid is poured over the fragile bones while they are still embedded in the rock.
A special hardening liquid is poured over the fossilized bones to prevent them from crumbling.
Naming the bones. As the bones are uncovered, their names and positions are recorded accurately on quarry map. The positions in which the bones are found may provide clues about how the dinosaur died, and the surrounding rock may help to shed light on the environment in which dinosaur met its death. Here they are note taking, and excavator notes down his observation as the bones are revealed.
The dinosaur's bones are individually identified and their positions marked on a quarry map.
Pedestaling. Once the tops and side of the bone has been uncovered, the next stage is pedestal it. This involves tunneling under the bones uh, on all sides, but leaving the pedestals pillars of the rock underneath the bone to support it. Pedestaling is very useful when excavating large dinosaur bones. It enables excavators to continue working on the bones while they are still anchored in their original position. Here, the pedestal fossil, this bone has been undercut on the all sides so that it is supported on three pedestals. Uh, plasterizing the bones. Plasterizing the bones. Pieces of Pieces of cloth soaked in a white plaster in a white plaster mixture are wrapped around the exposed bones. The plaster hardens around the bones and protects them in preparation for transportation. The bone bundles are then detached from their pedestals, and any uncovered parts of the bones are plastered over. Wrapping up, excavators on site wrap the bundles of fossilized bones in plaster jackets.
Strips of material soaked in plaster are wrapped around the dinosaurs' bones to protect them.
Leaving the site, once wrapped in plaster, the bones are tied together with the strong straps and hoisted into a back of the truck. The journey to the museum now begins. On arrival at the museum, the dinosaur bones are cleaned and prepared for study. Skeleton may even be assembled for display in the museum. Safety measures, the large heavy bone bundles are strapped up for safety while uh, in transit.
The plaster-wrapped bones are strapped up, ready to be transported to the museum for cleaning and studying.
Excavating dinosaurs. Digging up dinosaurs means first finding where their remains are like to be. Dinosaur hunters must concentrate on rocks formed from sediments laid down in Mesozoic times, 248 to 65 million years ago. Only certain regions of the world and certain types of the land provide rich hunting ground. Sometimes amateur discover dinosaurs by chance, but most finds result from plant fossil hunts by paleontologists, scientists who study fossils. Once located, a small isolated dinosaur fossil may be collected single-handedly in a few minutes, but prime big fossils from hard rock can take large team weeks or even months. Excavating is only part of the work. Measuring and recording full details uh, of the find are equally important. Once they are excavated, fragile bones need careful cushioning and labeling before being transported to an often distant museum. Where to excavate, best prices for hunting dinosaurs are explored in Mesozoic rocks derived from sediments that accumulated on land or close to the shore. This can mean roadside cuttings, quarries, sea cliffs, riverbanks, and even coal mines. But the most extensive dinosaur-rich outcrops occur among badlands and remote deserts, such as parts of the western North America, the Gobi Desert in Asia, Patagonia in Argentina, and some sandy tracts of the Sahara in Africa. Here, the erosion lays bare great tracks of fossil-bearing Mesozoic rock. Unfortunately, such much dinosaur bearing rock can never explode. It lies deeply buried under the rocks, soil, water, or ice, has been deformed by heat and pressure, and or has been worn away by erosion. Dinosaur discovery. This is an accidental. It can be accidental or planned. For example, discovery of iguanodon is said to have been begun when English doctor Gideon Mantel's wife Mary noticed the fossil tooth in a heap of roadside stones in 1820. Farmers and road railroad workers have also made important finds. Amateur and weekend fossil hunters are often armed with no more than geological hammer, have also been known to strike fossil gold, as when John Whiffen discovered New Zealand's first known dinosaur, an unnamed theropod beast-footed dinosaur. Bill Walker found baryonyx claw in England, and Eddie and Vivian Jones located a new dinosaurs in Colorado, but a large number of major discoveries have occurred on a long-term expeditions to remote regions, usually organized by universities or museums. Teams of paleontologists set off in trucks loaded with the gear for excavating, surveying, and packing fossil finds. Rebuilding dinosaurs. Recovery of a dinosaur fossil is the first step on a journey of discovery. When a museum laboratory has preparing a specimen, the paleontologist scientists who studies the fossils compared it with the known dinosaurs. Differences may indicate that a completely new dinosaur has been discovered. A description of the specimen is published in a scientific journal. When studies are complete, experts may reconstruct the creature's skeleton and put it on display. Thanks to international collaboration, hundreds of dinosaur displays have been developed around the world. At least 3 dozen institutions hold about 500 original specimens from Alberta Dinosaur Provincial Park alone. Area to area, park is perhaps the world's richest gold mine fossil dinosaurs. In the laboratory, work of the museum laboratory began freeing a fossil from its surrounding rock. The protective jacket is cut away by preparator. Someone who prepares scientific specimens, who then strengthen and exposed fragile bone with chemical solutions. A saw and hammer and chisel can be used to remove the outer rock. If that softer than the fossil it surrounds, it blazing where tiny speed plastic pellets are fired at the specimen inside the steel and glass cabinet can be used. If the rock is a limestone, dissolve in the rock. It's a rocky limestone, and the preparator can use dilute acetic acid to dissolve the rock, leaving the fossil unharmed. Final treatment, though, is often slow, painstaking work with a magnifying glass or microscope and dental pick and needle. Removing a huge dinosaur from the rock that is hard as a concern. The trait could take anything up to 10 years. Extracting the rock inside the fossil skull or eggshell may be impossible, but X-rays and CAT scans, computerized X-rays, may detect an internal embryo or brain cavity. Scientific study. Paleontology first compares the prepared newly discovered bones with equivalent bones from the known dinosaurs. Bones with unusual features may mean that the completely new dinosaur has been found. Paleontologists photograph these features to illustrate the scientific paper in which bones are described. Details of skull, teeth, limb bones, and backbones may help a writer draw conclusion about size, appearance, and behavior of the dinosaur. Finally, the article gives the animals and a scientific name. Independent expert must approve the description of the new dinosaur before a scientific journal can publish it. Reconstruction. Once scientists have worked out how dinosaur bones fit together, museum may want to reconstruct the skeleton for display in a life-like pose. Skeletons seldom survive intact, but museum staff can fiberglass models of the missing bones. Heavy mineralized bones need thick rods and bars to hold them. Nowadays, the most big mounted skeletons are light fiberglass replicas supported by slim metal rods invisibly threaded inside. Hidden treasure troves. Dinosaurs can the dinosaurs that public sees are often only fraction of fossils kept in the storage. For instance, the Earth Science Museum, Brigham Young University, Provo, Utah, has a stockpile of 90 tons, 100 tons of 100 imperial tons of big fossilized bones are still encased in plaster. Many museum basement is similarly cramped with labeled bones laid on racks or placed in drawers. Most of these lie there unexamined for years, waiting for scientists to study them. Sometimes paleontologists identified brand new dinosaur from one or two bones found in a century ago and left in storage undescribed or misidentified. Backroom work, much of what we know of dinosaurs springs from backroom work is in museum and university laboratories. Once the only guide to when these creatures lived was the relative ages of fossil bearing rocks layering laid down on top of the another. The youngest layer usually uppermost. Now radiometric dating can be used in order to pinpoint the age of dinosaurs with million years or so. In radiometric dating, the special instrument I used to measure the radioactive elements in certain rocks. These elements decay into others at known rates, so their relative proportions enable scientists to work out age of the rock, thus also the age of the fossils within it.